Boom! Alright folks, alright, so we're continuing in this series of videos where we're dealing with the topic of completing the squares. So as promised in the previous video, in this video we're going to deal with odd coefficients of x. Alright, so let me get to the program. Let me do it one time. So again, we starting off by writing out the final format in which the answer would appear: a into x plus h squared plus k. Alright, so we starting with x squared plus x minus 6, and we want to write this quadratic, which is expressed here in the standard form. We want to have it looking something like this in the vertex form. Alright, so again we say doing the same thing with it there, x plus, now the coefficient of x here is 1, so 1 will be, half of 1 will be a half, x plus a half squared minus a half all squared. Alright, and we would have done that, we would have basically taken this and expressed it like that, and we transform this to this, and we still have minus 6 on the outside over here. Now here is where the arithmetic starts to get complicated, and this is where there is a divergence of methods, because different people will add and subtract fractions differently. What I would do in my video here is present what I would do, right? And I don't want to necessarily go into all the different methods, right, just for the sake of brevity. So what I encourage you to do, right, we're not pressuring people to do anything necessarily how I would do it exactly. The only thing we pressure you to do is get the correct answer at the end, right? So whatever you do, make sure that the arithmetic is on point. So whatever your chosen method is to add two fractions or to subtract two fractions, just make sure that you do your arithmetic correctly. Most especially when you have negative signs in the mix, and it is almost guaranteed that you'll get the same answer that I get in my work in here. Alright, so follow what I am doing by all means. Listen carefully to what I am saying so that you can understand the method that I am applying. But there is no, we're not discouraging anybody from doing whatever works for them. If it works for you, you go right ahead and do it. Just make sure you do it correctly and get the correct answer. Right, so we continue. Now this is fine, we don't have to interfere with this again. Here now is where the things start to get nice. So the next line would be x plus a half, all in brackets, to be squared, minus a half squared is 1 over 4 minus 6. Now this is what I would do. We have a fraction here with 4 in the denominator, and we're interacting it with an integer. Now this integer 6 could be expressed as an improper fraction. We could express 6 as any improper fraction. We could say 6 is the same thing as 6 over 1. We could say 6 is the same thing as 12 over 2. We could say 6 is the same thing as 18 over 3. We could say 6 is the same thing as 24 over 4. We could say 6 is 600 over 100. We could say 6 is 6,000 over 6,000. We could say 6 is 6 million over a million, etc., etc., etc. So as the circumstance demands, we have a certain degree of flexibility in terms of how we could express any given integer. So we express the integer as a fraction, as an improper fraction, which it must be by definition, because an integer is just the integer divided by 1. So we could express any integer as a relevant improper fraction, and thereafter the main concern would be how we are interacting that improper fraction with whatever else you're doing in the course of the problem. So in this case, because we already have a fraction here with a denominator of 4, I would take this 6 and express it as 24 over 4. You see here why it is so important to know your tables. So it will be x plus, writing properly, x plus a half, in brackets, all to be squared, minus 1 over 4 minus 24 over 4. Now, like this, the arithmetic where the fractions is concerned is a lot more simple. You don't have to worry about finding the LCM and all them kind of things, because you already have the two denominators as the same. So with these two denominators being the same, in other words, with a common denominator, you can now perform all the arithmetic at the level of the numerator. So the next line here would simply be the x plus a half, all in brackets to be squared, remains intact. And this will be the same thing as minus 1 minus 24 over 4. Right? And then that will just be x plus a half, all to be squared, minus 25 over 4. Alright? With the two 4's here, you could just say minus 1 minus 24 is minus 25, and I could get from here to here in one line. Alright? So if I am working this out personally, by the time I reach here, from the time, well, I would have had the 6 here, and from the time I see this 1 over 4, I would immediately switch this to 24 over 4. So I would move from here to here in one line, and then from here to here. Alright? But for the sake of instruction and explanation, I would include the extra line here just to make it a little more expansive for the sake of somebody who might be kind of now picking it up. Alright? Maybe for the first time. Alright? So in this case, the relevant values are your A would still be 1, your H would be a half, and your K would be minus 25 over 4. Alright? So you need to start getting accustomed to fractional values, right? Both in terms of your final values of the constants here, and in terms of your values in the course of the working. It will not always be straightforward integers as we would have had in the first couple of examples, where we would have started with a even coefficient of x on the top here. Alright? Now, just as we did in the previous two videos, we're going to take the step of working backwards. So if we start from here and we work backwards, we want to see if we will get here. Alright? And you could take this as probably a further exposition, if I could use that word, of dealing with fractions. So for the sake of argument, for the sake of satisfying any latent curiosity, this is what we're going to do. So what the final answer was? The final answer was x, right? So where am I blue marker? Right. So if I take x plus a half, all in brackets to be squared, and a minus 25 over 4 from it, and I want to work that out, what would I get? Would I get this? Well, let me check it out. Alright, so we know from the regular expansion of a plus b in brackets all to be squared, which I'm not going to discuss now. We did that in the very first video. Alright, this all to be squared will be x squared plus x. A half by 2 is 1, plus a half squared will be 1 over 4. Alright, this will be plus 1 over 4, and we minus in 25 over 4 here. Right? Come. Look, right. So this is what we will get when we expand this. And of course, 1 over 4 minus 25 over 4 will be x squared plus x minus 24 over 4. Again, you see how important it is to be able to manipulate your fractions. And of course, we know that minus 24 over 4 is, guess what? X squared plus x minus 6. Alright? So again, just for the sake of curiosity, satisfaction, I'm taking the extra step in these videos to work back from the solution to see, to verify in fact that we get the original expression that we started with. So we're going to go straight to the next question now. If we have, let us clean the board first. If we have the question, and the next question is as follows. If we have the expression, let us say x squared minus 9x plus 8, and we want to write that over in the vertex form, a into x plus h squared plus k. Alright, so again, we take this little part here, boom boom, and we write that over using the method that we have been discussing in the last few videos. That will simply be x minus 9 over 2 squared minus 9 over 2, all in brackets to be squared, plus 8. So you see here how straightforward it is when you're working in fractions, because you don't want to introduce decimals here, because when you do that, you get minus 4, you get 4.5 squared here. Alright, you square that, you get some, I think it's 20.25 or something, if I'm not mistaken. Right, I might be wrong on that. I just wait, I have a calculator here somewhere. Hold on. 4.5 squared is 4.5 squared is equal to, yes, 20.25, right? Sometimes I remember these things, sometimes I don't always remember it correctly. So yes, 20.25 is 4.5 squared, right? And then you had to interact minus 20.25 with 8, which is minus 11.75 or something around there, right? We don't want that. We don't want that, because sometimes what happens is that you get these questions and the completion of the square is the precursor to something else coming down, and the something else coming down afterwards depends on you having the answer not in a decimal form. Alright? Or you might get this as the very last part of a question. They might give you a rectangular field or something and blah 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 blah, ding 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 ding, and they might say solve by completing the square or whatever it is. There are so many ways, so many permutations of bringing these things. Alright? So again, I want to discourage people, do not introduce decimals in these things. Alright? So we're going again. So we would have expressed this as this, and the next step is to just do the algebra. So watch it now. X minus 9 over 2. Remember, we're not interfering with this at all. Minus 9 over 2 squared is, what is in brackets now? 81 over 4. And then we plus 8. Right? So having kept the 9 over 2 squared as a single entity, I could then, I will just for the sake of being extra careful here, I'm going to just leave it as minus 81 over 4 plus 8. Right? Well, I'm going to switch this now. So the 9 over 2 in brackets remains by itself, and we square that first. We're not interfering with this minus sign at all. That minus sign is that minus sign is that minus sign, and it stays there. It stays there here, it stays there here, and it stays there here as well. So we square the 9 over 2, which is the 81 over 4. 9 squared is 81, of course, and 2 squared is 4. And this is what we get. Alright? Now, your next move is to express the 8 as, guess what? 32 over 4. Right? That way, we now have a situation where we have 4 in the both denominators, and we could just do the algebra right across the board there. Alright? So we come now and we say that this is the same thing as x minus 9 over 2, or to be squared. Alright? Minus 81 plus 32 is minus 49. So you'll get minus 49 over 4. Alright? And that is the answer. That is the answer. Now, again, for the sake of, no, let me write out the A. Right? The A is equal to 1. Your H is equal to minus 9 over 2. And your K is equal to minus 49 over 4. Alright? Now, again, just for the sake of argument, just for the sake of curiosity, right? We're going to take the final answer at the end and work backwards and verify that we get whatever we have on the top there. Alright? So we're going to rub off these fellas here now. Don't forget, you always have the option to rewind or to pause. So we're starting off with x minus 9 over 2 squared, and we minus in 49 over 4 from that, and we want to verify that in truth and in fact we'll end up with this here, x squared minus 9x plus 8. Alright, so we rub off our friends here. No, we don't need these fellas here again. So in accordance with the expansion that we did in the very first video, this will be written over as x squared minus 9x plus 9 over 2 squared will be 81 over 4, and then we minus back the 49 over 4 here. You see the 4 here and you see the 4 here in the denominator. So in interacting these two fractions, all we need to do is just perform the arithmetic at the top, at the level of the numerator, so that we will now have x squared minus 9x, 81 minus 49 is, plus 32 over 4, and we know that 32 over 4 is our good friend 8, and that, ladies and gentlemen, boys and girls, is the solution worked backwards. So in other words, if you have the opportunity to verify the solution by taking the answer and working backwards to verify that you get the original answer, then by all means do that. But if you really go the extra mile in terms of working enough of these questions, there is a very good chance that you wouldn't even need to do that. You will just know, you'll have sufficient confidence in the process. But to do that, you have to be careful in your working. You have to be, don't try to go too fast, especially when you're learning it. Speed is not the first goal. The first goal is accuracy. The speed will come in the course of time as you start to get smoother and smoother with it. Alright, so that is it. We have just worked out in the last couple of videos some completion of the square. So I want to take this opportunity to encourage you to find an exercise somewhere. There is a plethora, or is, whatever. There are a plethora. There is a plethora, whatever. There is a multitude. There is a multitude of AdMaths textbooks in real life, and there is a multitude of exercises online. You just go on Google and you site and you do a search. Exercises on completing the square. Right? You could even go as far as searching for a particular type of file. So if you want it as a PDF, you could put completing the square worksheet, PDF, completing the square worksheet, Word, etc., etc. And chances are a file will show up somewhere that you could download and just go work questions, check your answers, practice, so that you put yourself in a position to improve as you go along, because we're going to be increasing the difficulty as we go along. Alright, so keep good, take care of yourself, and look out for the next video.